we are at the NLP after party event. I'm here with David DeMaris, and we're going to talk a little bit about Hanson Robotics.
Hey, thanks, Steve. So I've been working with Hanson Robotics for about a year. Started part-time in June and full-time since November. And a lot of the work that I've done there has been in the sort of expressive part of natural language processing. So we have text-to-speech, and one of the first things that I was asked to do was to kind of make the chat bot that's integrated into the robot more expressive. And so I started by picking up a sentiment analysis dictionary from somewhere that was an open source thing and incorporating that and sort of steering the emotional expression. We were using a commercial speech synthesizer, so I would sort of look at what was said and kind of mirror back the same emotion, which is not what you would always want if you're like, I don't know, a suicide prevention counselor or something. It's probably best that, you know, your emotion is a little more consistent. But in general, this kind of like the sort of musicality of speech is something that's very interesting for me for a long time, and expression in general. So the next thing that I was asked to look at was what we called procedural animation, which is to some extent the sort of like the play of expression on your face in various situations. So there was a little bit of just kind of random, like, let's show off the expressions the robot can do. And I said, well, that's pretty inappropriate for conversational dynamics to just kind of randomly switch, right? So I did a little research there and looked at things like the research on, say, blink rates and this kind of things based on sort of sentiment and expression and mood. So I basically said, okay, if we're starting a conversation, like once speech becomes active, can we, first of all, kind of tone down, like eliminate some of the emotions from being expressed during the conversation, and but we can have some subtle, like, empathetic shifts so that if you're happy, the blink rate is a little faster. If you're slow or maybe even very thoughtful and pensive, which is not really a thing that's going on, but so that's, you know, all those kind of things that, like, how that the interlock of the sort of cognitive underpinning of conversation with the kind of musical expression. And you know, we mentioned just briefly a talk that I gave recently called Rhythm and Collective Intelligence, and one of the sort of related topics that I got to was it's very clear that when people are having a conversation, there's a lot of context and a lot of things that are really difficult to do in a robot are cued by this kind of nonverbal interaction. If you've ever tried to dictate into Google Speech, for example, and this is a big problem that we have, we actually use Google Speech to do the translation. It never knows when a turn is over, right? And we actually cue those things by blinking in a lot of cases. So I did some things like when the robot begins to speak, it with very high probability blinks, and when its turn is done, when it's pronouncing the next to last syllable, with very high probability it will blink then. So it has no idea when you're done, although we have sort of perceptual systems that could pay attention to those kind of cues. So and in that talk, like, one of the things that I was talking about is there is kind of a lot of interesting research starting to happen now about both how people steer conversations with this kind of nonverbal interaction, but also how they basically are kind of like creating a shared neural space and a shared kind of idea space. One of the things that we've been working on there is kind of some teaching of dialogue, or experimenting with, like, improvisational actors for kind of defining the chat space. And there are various groups around that are working on techniques that improv acting schools use to say, like, you don't know who each other are, so you're kind of like determining this world and guessing what it is and who each other are. And it's not completely different than what we do all the time in normal conversation. And it's a little bit different from, I think, the historical, like, sort of very individual-centric idea that, you know, like, I'm me and I have ideas, you're you have ideas, I have ideas about your ideas, so there's this theory of mind. And I think it's pretty exciting, this kind of co-creation idea where it's like, yeah, I do have some ideas, you probably do too, but we're also sort of like building this thing that neither of us has, and we're doing that all the time. That's an interesting take on it. I've been working on a chat bot for the last few months that's, I didn't really have a chance to go off and do a lot of research ahead of time to say, like, how prevalent or unique is this, but it's open source, so I can actually talk about it a little bit. And what we basically did is a kind of tiered system where you have many responders, and we can kind of mix some that are pattern matching responders, which is kind of the old, very simple kind of chatbot that's around, and then other layers that are a little bit more like statistics driven, sort of bag of words matching driven, so that if we don't have an exact match, even in the same sort of canned response corpus, we can say, like, can we use those techniques to discover something that would be a good response? Or we could have some big data mined set of answers from any corpus that you want, and we could just say, well, I don't have a character-specific answer to this, but I can kind of come up with a reasonable response out of this very big corpus. And then if those don't work, you fall back to yet another layer, which is a super general, I've got an answer for everything chatbot. I'm just not very interesting to talk to. You know?
And what is the name of that open source chatbot?
Yeah, you know, it is out in the Hanson Robotics space, but I think it's called ChatHub, and it is so it's a server architecture. We have a version of it that runs on an Amazon web server that we can use for sort of like multi-person testing and experimenting. I believe it's called ChatHub, but it's like the name, nobody gave a lot of thought to the name, and we're generally taking a lot of work that was intended to be open source, and for various reasons it was sort of behind the firewall, and now there's a version of stuff that's all open source, and that's a part of that system that you can use. So now I'm actually returning to work on expressive speech again, and I think one of the early things that I'm going to do is, because we moved to, or at least we're distributing an open source version that does not have the kind of like be happy, be sad, you know, it's a bit monotone. So we're going to try to do some post-processing based on some papers and existing work that's out there that says, like, if you can both do natural language analysis of what is said, or just even look at the inflection points of what is there with some kind of natural speech, and then increase the range, modify the rates based on sentiment or what you're trying to express, and a little bit of like pauses and hesitancy. That we would actually like to do something there where, like, we have a kind of elaborate system called OpenCog that is sort of the new thing that's being integrated in there, that is a little bit more legitimately thinking or making some effort. There's natural language understanding, there are goal systems, and so if there's a very easy resolution, then, you know, that I think some of our pauses and hesitancy and some of the expression just comes from, like, how hard is it for me to figure out not what I need to say, or maybe like it's really conflicty. It's like I've got to tell you something that's hard. It's gonna. One of my goals is to preserve my relationship with you, and I'm gonna take a chance to tell you something that might break that relationship, or that it's like going to be hard for you to hear, and I don't want to see what happens to you. But
and so it adds these pauses to sort of emphasize like what I'm about to say could break your heart, and not just says you should comb your hair, and like, give it a second and think about it. Now, so does that mean, because it's open source system, does that mean maybe Stephen Hawking in the next couple of years will suddenly be more expressive with his dictation?
Yeah, I would think so. I don't know, like what he's got now. I mean, I think that he's working with a guy, and so one of my other great interests is neuroscience. Like I did a PhD at UT, and I kind of drifted away from the neural network machine learning, and eventually presented my work at like computational neuroscience. And within the great world of neuroscience, I'm kind of in the physicist subset, so people will call that like neurodynamics or neurophysics. And I co-taught a course sort of towards the end of my PhD, 2000, 2001, I guess, on that topic. And so I'm pretty happy to say that things have sort of come around to making it look like some of that stuff was a little bit prescient, in the sense that things that I was kind of trying to describe, a lot more people are working on now, and there's kind of a better, the language is more developed. Like I had to make up so much of the language for what I wanted to say, and now there's an audience, and I know the terms that I should use. Relating this back to Stephen Hawking, I know that he has somebody in a company that has what they call single channel EEG analysis. So he has like one sensor that can capture quite a bit of data, whereas conventionally you have many sensors and you try to make some sense out of what's going on in different brain regions and that kind of thing. So I think there's hope for Stephen Hawking to get, I don't really, like, I've never actually heard his speech synthesis that he's had. I heard a little bit of Roger Ebert's. There's a thing that goes on now called voice banking, and actually another system that we considered using is something that's intended for people that, let's say, like, that you have a very high risk of throat cancer or something, or maybe you're going to get surgery for it. Yeah. So you can actually train your voice, and then you can have a speech synthesizer that is really your voice.
Here's the funny thing: like, it seems like the more that I figure out about NLP and about human-machine communication, the more I really appreciate the human brain's innate ability to do all of these complex things. You don't realize, like, until you start taking it apart, it's like one of those pepper grinder calculators. It's like, oh, it's kind of stuck. Have you ever seen one of these things? Yeah, and it's stuck. Let me just open it up, and when you do, you just throw it in the garbage, because it's that's what it feels like. Like the human brain, it's just like you peel this back, you're like, oh, that's how it works, and then you just realize that it's much more complex than you can imagine.
Yeah, so I do have some ideas about the complexity and what the right metaphor is, and it's something that I might wind up writing a book for it, and that talk that I gave was kind of a prototype for that book. I think one of the terms that I can use for the way that I thought about things back in the 90s and continue to think about it is more like a neural field theory. So the term that comes up a little bit is this, and is quite widely used now, is recurrent neural networks. If you take one little recurrent node where the output feeds back into the input, which is the basic definition of that, and you let them talk to their neighbors, or maybe embed it in a kind of a small world network where each local node can kind of sense the whole field to some extent, then that starts to get a little bit more like what people think is going on in neuroscience. And that so there's the kind of idea that rather than strictly a network structure, I mean, it is a network structure, but it's almost like the network structure that is sort of underlying space-time and the formation of particles or something like that. This is something that I really didn't think about, but at a certain point, 5 or 6 years after my dissertation, I saw that, oh, somebody's using the same kind of math formalisms as a kind of variation on string theory. And it makes sense because there was always these things that people knew about, like Conway's life, where you had very simple rules, a spatial structure, and you would get these kind of particle fantastic things going on. And so I was kind of working in that, so you would call it like chaotic neural networks, where you had these little chaotic oscillators, and they would generate particle-like constructs. And so the kind of thing that made me a heretic within this school is I said, like, I don't see this as necessarily being opposed to symbols and symbol processing. So it turns out that there is a sort of subfield within, physics and statistical mechanics in particular, where you sort of chop the possible motions of particles or a collection of particles up into bins. So, like, if you just take a histogram of what's going on in the system, there's a way to think about that as the symbols. So you can say within this this region of this possible states, we can put a label on that that's like an alphabet symbol. That's called symbolic dynamics. So there were a few papers where people did, recurrent nets and language recognition and that kind of thing in the late 80s, early 90s. And what I basically did that I don't think anybody else did before or since was to say, well, if we just sort of generalize that to say the statistics of this whole thing is kind of a symbol space where you can occupy multiple symbols at once, and what if this kind of slow waves in EEG, part of their function is to do things that we do in machine learning all the time, like project up into higher dimensions, project down into lower dimensions, control the sparsity, this kind of thing. And when we actually use symbols, when we're doing this kind of ideation, thinking, the turning perception into language, that kind of coarse graining, as it's called, or symbol spaces is a key thing. So I was totally a Lone Ranger making this stuff up, just sort of watching what was on the screen and trying to explain it and, grind out a PhD. And it took about 7 or 8 years, but there are actually a couple of guys in Europe that started to eventually use the same language that I consider very sort of people who could understand immediately what I was talking about. And that would be some guys, Harold Ottmanspacher, who is actually at the Jung Institute in Zurich now, and a guy named Peter Beimgraben in Berlin, who are both physicists who, have some interest in brain science and cognition, that kind of thing.
So the book maybe 2017?
Well, I kind of really need to get on it, and I also, have some ideas about how to kind of revisit some of these techniques, and I'll probably make an open source version of this software that I did in my dissertation. I rewrote it in Python a couple of years ago, but then I made it sort of complicated and application specific, and the application was to generate music for an opera that I did here in Austin that was kind of about physics and consciousness. Perhaps you didn't see it. It was at the Vortex, and it was called For Fear the Glass May Shatter.
Not for not being interested. This sounds like it was something I would have gone to.
I would say, like, finding the audience was a bit of a challenge because I didn't really have time to, I was still writing music, the week before, and kind of trying to get this complicated software running in the booth. And I got to say, the nice thing about it was there were guys in the booth who knew more about cosmology and expansion theory than I did. I was able to find out. I'm like, this is making me feel a lot better about my tech crew. I think they can probably figure out how to run this Python code in the booth that's going to create some simulated universes or simulated minds that are generating music.
So yeah, it sounds like if there's maybe there's a data conference in New York, we can take it out on Broadway or some, and get to experience it, because your audience will be there,
Yeah, I think maybe the audience is elsewhere. There's kind of a joke, there are many jokes in the opera, and one of them is that it could close on opening night, but in the best case, you could hope for 4 or 5 towns. And I have the likely suspects identified already, so I need to work on that, I suppose. There was a half pun was in the opera there was a big argument in one of the early rehearsals, like people said, like, that's a mistake, right? And I'm like, no, it's actually on purpose. It's a half pun, and this whole conversation was they were trying to understand spin as a concept, and they had these mysterious, like, half quanta numbers that weren't working out. And I thought, like, a good way to talk about that would be with a half pun, and I didn't win that argument.
And so people were being a little bit over analytical with it.
Well, I think the director's idea was that this play was kind of only made for you, and I said, yeah, that's more or less right. I did write it for me, and I feel like it's not that limiting, but it was a lot of linguistic games going on in there, like constraints, that kind of thing.
It's very interesting. I want to is there a way that we can find out how things are developing as far as the robotics and as far as sort of the expression and systems that you're putting together? Is there a way we can sort of see a demo of that?
There are various demos online, and I think it's likely that as they become a little bit closer to product, that there will be more. I just saw some Wall Street Journal article or vlog kind of thing today that came out in the last couple of days that did use some of the chatbot work. The expressive stuff, I have to say that, like, one of the things that's a bit frustrating me there is that because I'm so far away and there are other people working on it, sometimes the things that I do seem to go kind of like disappear or get broken, and I'm actually looking forward to the open source version being out there, and I'm like, I can get in there and fix it, grab my own copy, and it will be like fixed forever, I gotcha.
Well, David, thanks so much for stopping and talking to us. I'll probably have to watch this video myself to make sure I get it all, because that was some really deep stuff. But
it's moving pretty fast there, I guess.
Awesome.
Right, man. Thank you. Good to talk to you.
You too.